Hello everyone, I'm a 4.0 pre-med, and one thing about me is I study smarter, not harder. So I'm going to show you guys my tips and tricks. Personally, I loved organic chemistry. It was definitely one of my favorite subjects in college, and I know that sounds really weird, but I really loved it. And the best part of organic chemistry for me personally was mechanisms. Now, synthesis on the other hand, I really didn't like, but I'll try to do some because for you guys, because I know that synthesis can be really hard for students. It was for me, but mechanisms, again, it was super natural to me. So in this video specifically, as you can see on the screen, I'm going to be talking about dehydration of alcohols. I'm going to give you two very common reactions that you're going to see in organic chemistry, one being dehydration of sulfuric acid and the other being the dehydration of cyclopentanol. So let's begin. So firstly, for the dehydration reaction, dehydration means, well, D is like the removal, right? And then hydration is water. So really what you're doing is you're removing a water, you're losing a water in this reaction. So it's something, actually, I probably should have write that you, in the whole net reaction, it's a minus an H2O. Again, you're not gonna really see anyone say minus H2O. I mean, you might in biochemistry, but I mean, for organic chemistry, usually they don't write subtract H2O. They usually don't. I mean, I personally didn't see that. But again, that's what dehydration is, just to make it easier for you guys to kind of see like what you're doing in the process. And that can kind of help you know where the mechanism needs to go instead of just memorizing it. With that being said, let's begin this mechanism. So the OH is going to, it has two pairs of electrons. It doesn't matter which pair you grab, just grab one. And it's going to attack that hydrogen. So it's going to attack the hydrogen, and then these electrons between this hydrogen in blue and the oxygen, the electrons are going to go, and again, that's a funky arrow. I'm really particular now about arrows, and I think that's because I was so drilled in organic chemistry that my arrows had to be perfect. If not, I would lose points. So I'm going to drill you guys too. So again, those electrons go to the oxygen, and you have a water, but notice that you have a formal charge. And so some students don't understand why you need to put a positive or why you need to put a negative, and it's because the positive or negative kind of shows you what you have, how many bonds you have formed. For this in particular, I'm going to show you really quickly that the valence electrons, the formal charge equals your valence electrons minus your bonds plus your dots. Oxygen has a valence electrons of 6. There's 3 bonds and there's 2 dots. So that's going to be 6 minus 5, which is positive 1, which is why you have a positive charge. Well, so you have your water per se with a positive charge, and so water doesn't like that. And water is going to say, you know what, I'm going to help you out, and it's going to leave. So then these electrons are going to go to the water so it can leave and have its 6 in a formal charge of 0. So sometimes you'll see in biochemistry, they'll put like minus H2O. I don't see it that much in OCHEM, but I mean, just know that if you see minus H2O, it just means it's losing water, which again is what a dehydration means. So it loses the water and it forms a tertiary carbocation, which is excellent. And then from the first step, we had H2SO4, but it lost the hydrogen, remember? So it's going to have HSO4 minus. So then these electrons from the oxygen is going to want to reform itself. So it's going to go and grab, it's going to go and grab that hydrogen, and then those electrons between the blue hydrogen and the carbon are going to go and form the alkene for us, which is what we form in this reaction. So definitely sometimes you'll also see for the reaction, instead of doing the whole mechanism, they'll just write this OH line H2SO4 with a heat, which is the triangle, well, but that signifies heat, and then just draw the product. So I just want you guys to be conscious about, you don't always have to show the mechanism unless they ask you specifically to. For example, in synthesis, you're not showing the mechanism, you're just showing what each reaction will produce. So just keep that in mind. The other famous dehydration that you see a lot in organic chemistry, especially in OCHEM 1, is dehydration of cyclopentanol. And what they'll show you is they'll show you the reagent POCl3 and pyridine. And I didn't personally learn the mechanism for this one. I mean, I can look it up and show you guys if you're really interested, but in general, you just need to know that this is a reagent that produces alkenes as well. And I made a mnemonic for you guys because I'm really heavy on mnemonics to remember my things, because obviously in organic chemistry, you have so many things to remember. So I just put place on carbon line. So you have an alkene that's formed. If it helps you, great. And if it doesn't, well, I think it's amazing. So if you like this video, please follow me here and on YouTube. It helps me out, and it helps other students out as well, because they'll be able to see this content. So again, if you enjoyed the video, please like and comment. Thanks again for watching, and have a great day.